In this video, we're just going to review finding the area between curves. So the functions x squared minus 5 and x plus 1, you can see them graphed here below, and we're going to find the area between them. Now, on my graph, I labeled the points where they intersect. You would not need the graph to find the intersection points. We could certainly do that by hand, by setting the two equal to each other, x squared minus 5 equals x plus 1. With something like this, I like to get everything to one side, so maybe I can use either quadratic formula or factoring or something. So I'm going to subtract the x and the 1, so I have this, and then it's very easily factorable to x minus 3 and x plus 2. So again, now you can see that these intersection points, we've got -2 and +3. So we wouldn't need the graph to find those, but so -2 to +3. And we always do the top function, which in our case is the line, minus the bottom function. Now you could combine some like terms right here, or maybe clean that up. I guess I would recommend that. It makes life a little bit easier later, to have x plus 1 minus x squared plus 5, which then we could say is x minus x squared plus 6, like that. So the antiderivative, well, we'd have 1/2 x squared minus 1/3 x cubed plus 6x, and we're going to evaluate that at 3 and -2. So we plug in 3, and we get 9/2 minus 9 plus 18. We plug in -2, we get 2 plus 8/3 minus 12. And you could certainly now, start to maybe do this by saying, -9 plus 18, so this is 9, 2 minus 10, we get, or 12 is -10, and you could have, 19 plus 9/2 minus 8/3. It comes out to be 125/6. You might want to check that to make sure you can get to that point, but I'm going to rely on the fact that you can combine those things. Let's do one more. So again, you can see my graph here. We've got x squared minus 4 and 4 minus x squared. I put the intersection points in there, but again, you wouldn't necessarily need that. You could have x squared minus 4 equals 4 minus x squared, and maybe add x squared to both sides, subtract 4, so you could then factor the 2 out. So pretty easy to see it's going to be 2 and -2. Okay. So in this case, the top function is 4 minus x squared. Bottom function is x squared minus 4. So top function minus bottom function. Again, maybe you want to combine your like terms right away. We have 4 minus -4, so that's +8. We have -x squared minus x squared, so that's -2x squared, like that. So my antiderivative would be 8x minus 2/3 x cubed. We're going to evaluate that at 2 and -2. So we've got 16 minus 16/3, and plugging in -2, we have -16 plus 16/3. And again, if you combine everything and you put this together, you should end up with 64 thirds as your final answer. And again, you might want to check that just to make sure. But remember, we find the intersection points and we do the top function minus the bottom function. And we can combine some terms if that makes it easier. You don't have to. Then we plug in the top bound, plug in the bottom bound, and find the difference.